Heggenstaller, an agronomist with Pioneer Hybrids. We're here today at a Pioneer field research trial where we're focusing on issues related to residue management. Residue management, especially for growers growing corn after corn. Residue is an increasing challenge, especially as yield levels increase and as the strength of corn stalks increases through breeding efforts. One of the most effective ways potentially to deal with corn residues is to actually remove a portion of the residues from a field. In this trial, that's precisely what we're looking at. We have strips here, and in every other strip we've removed about 2 tons per acre of stover, and then in the alternating strips we've left as a control where we've left the stover on the field. Corn stover can interfere with a subsequent corn crop in a couple of ways. Most immediately, it can be a physical barrier and interference with planting and planting efficiency. It can then reduce the speed of crop emergence, and then it can go on to mobilize nitrogen in the soil and reduce early crop growth by limiting the amount of nitrogen available to the crop. And finally, corn residues can carry with them pathogens such as early season leaf pathogens that reduce crop vigor and health as well. So what we're looking at here is by removing a portion of the stover, can we offset some of those disadvantages associated with growing corn after corn. Let's go and take a look at 2 of the different strips and see exactly what I'm talking about. We're here in one of the strips where we left the stover on the field last fall, and as you can see, it's been replanted to corn this spring. And we can see a lot of residue here on the field. The row cleaners at planting and the trash whippers, they got a good bit of the residue out of the row, but we can see here this spot shows pretty clearly the kind of problems corn residue can cause. We can see that the plants are, while they're coming up through the residue, they're struggling to get up through it, and there's a lot of material on the field that's slowing the warming of the soil because it's reflecting light and heat back off the soil. So we'll go over here in a second now and take a look at a strip where we removed some corn stover and compare the field condition there and the plant status there and the evenness compared to this spot. We're now on one of the strips where last fall we harvested roughly, removed by baling and raking, roughly 2 tons to the acre of corn stover and planted back to corn this spring, and we can see a marked difference in the crop establishment, uniformity, and the amount of residue on the soil surface. There still is some residue here, and certainly through the winter before the spring tillage there was some residue here to protect the soil, but now with the crop coming up into this darker soil, less reflectance, less nitrogen immobilization, we get a more uniform crop. Each of these plants about 5 to 7 inches apart. You see no skips or due to failure to emerge or slow emergence, and we just get off to a better start in a corn-on-corn scenario. So we'll continue to monitor these fields throughout the year, these trials, and try to get an idea if these benefits that we see early in the season, beyond the efficiency and ease of management benefits in the spring, if this can also translate into a yield benefit in the fall.